recording now in case I forget later. So X values, your domain. How far can you go this way or this way with this graph? Your X values. Could you plug 1,000,000 into that graph? You could, right? Your domain is all real numbers. You can go -1,000,000, you can go +1,000,000, you can, all real numbers, okay? But your range is not all real numbers. What's your range?
Y is greater than or equal to.
Yes, y will be greater than or equal to 2. Here, right? That's your lowest y value on your graph. There can be no y's this way because the graph opens up, okay? So your range is going to be y is greater than or equal to 2 for that. Good morning, Meg. How are you? Thank you. Brooklyn, this is for you. Okay, find the inverse. How do you find an inverse? Switch your x and y. So they're saying the inverse of our f of x function. Where did I put those? Here we go. F of x is here, right? Now, don't let f of x throw you off. F of x is essentially what variable? It's y, right? So if you see f of x equals 5x plus 3, and you prefer to call it y equals 5x plus 3, that's what I would do if I were you, right? So this is your f of x function. The inverse is going to say swap. So switch these where they are, and then solve for y. So it's going to be x equals 5y plus 3. How do you solve for y there? Take away the 3 from both sides. So x minus 3 equals 5y. And then divide by 5. So y equals x minus 3 over 5. Well, that means my inverse function is, can't see my screen right now, x minus 3 over 5, right? That's your inverse function. God bless you. Questions on that? Okay, then look at g of x. Our g of x function was what? X squared plus 2. So we're going to start with that as y equals x squared plus 2, right? That's the g of x function. What are you going to do first to find the inverse? Swap them. Yeah, swap your x and your y. So we're going to do, sorry, I got to move. The sun is creeping on me. So we're going to do this. X equals y squared plus 2. So now if we're going to solve for y, we're going to take away 2. So it's x minus 2 equals y squared. And then what? Square root both sides, which means plus or minus. Good. So this is going to be plus or minus. So we get y equals plus or minus the square root of x minus 2. So that's your inverse. If you write it with inverse notation, it would look like this. Okay? Yeah. Say that again. I square rooted, right? Because right now, if you look right here, right, it was y squared plus 2. We took away the 2. So it's y squared equals x minus 2. But we don't want y squared. We want y. So to solve for y, if you have something squared, you square root it to undo that. So we square root both sides, and we get this. Okay? Okay, graph y equals 2x minus 6, and then graph the inverse. So this is very similar to what we did on the quiz, right? You're going to plot your minus 6, 1, 2, 3, 4, 5, 6, and then a slope of 2. So up 2 over 1, up 2 over 1, up 2 over 1. Okay, so here's your line. If you're going to graph the inverse, just pick 2 points. All you need is 2 points. You don't need to do a whole bunch of them. Pick 2 points that we can flip-flop. So right now, if we're just going to pick 2 points on here. Do you want to pick 2? Do you want me to pick 2? I really don't care. I gave you 4.
Just the ones on the y-axis.
The one on the axes, that's what I would do too. So this one is 3, 0. And then your y-axis is 0, -6. Okay, so that's the original function. To find the inverse, we just flip it. So our inverse function is going to be 0, 3, and -6, 0. So 0, 3, 1, 2, 3, and -6, 0, 1, 2, 3, 4, 5, 6. Goes like that. And remember, these always reflect over the line y equals x, so you can always double check that. Like, does this look, oops, like a reflection? That's terrible. Sorry. Undo. A reflection over that line. And it does. Good? Yeah. I can't hear you, Jada. Sorry.
I was saying that I was kind of confused how the x and y.
So I graphed this y equals 2x minus 6 in slope-intercept form, right? So this is your y-intercept. So I plotted this point, my -6, and then I did my slope up 2 over 1, up 2 over 1, up 2 over 1. So that's how I got my first line. I just picked 2 points on that line to write down. So I picked this point and I picked this point, right? That's these 2 points. So then the inverse just takes those 2 points and flips your x's and y's. So that became this. When I swapped these, I got 0, 3. When I swapped these, I got -6, 0.
So the 3 and 0 he did by the 2 points and the 0 and then
So yeah, this was 0, -6, right? This was 3, 0. So I just named those points from the graph that we had already made. Okay? Okay. Page 1 down. Do you need a little stretch break? Doing okay? Here we go. Okay, so no negative exponents, right? We don't want negative exponents. So we're going to simplify as much as we can. What is a 1/3 exponent doing to a number? Cube rooting, right? So 3 to the 1/3 power is the cube root of 3. 9 to the 1/3 power is the cube root of 9. What can you do with that? Multiply them. We're going to go 3 times 9. So it's going to be the cube root still of 27, okay? And at that point, you may plug that into your calculator. I want to see this. I want to see that you know how to get there. But then you may plug it into your calculator at that point. And you maybe just know it off the top of your head because that's a very common one. What is the cube root of 27? 3. Okay, so there's your answer. Put a box or a circle or a highlight with it. That'll be great. Okay, 17. You have 27x to the 12th, and we're taking the whole thing to the 2/3 power. What's the first thing you do?
Convert the 2 over 3 to the other form. Yeah.
For the number, right? So we're going to take both things to the 2/3 power here, which means we're going to take 27 to the 2nd power, and we're cube rooting, right? That's 27 to the 2/3 power. And then you'll do the same thing here, but we don't have to do all the conversions because we can just multiply those exponents. So 12 times 2 is 24. 24 divided by 3 is 8. So that's going to be x to the 8th power, okay? Now, how did I get what? To the 8th? I did 12 times 2 divided by 3. I just multiplied 12 times 2/3. Yep.
Can you put 27x squared under the same radical? Have it all under the cube.
With,
Yeah, put 27 x to the 12 and then do all that.
yeah, just rearrange the order you're doing it in. Yeah. Yes, you totally can. Just be careful that your numbers don't get wonky when you, I feel like there's more room for error when you don't just simplify this stuff right away. But it's not wrong to stick it all under there and then take the 2/3 power of it. Okay, so I would cube root 27 first, which is what? 3, and 3 squared is 9, right? So you get 9 times x to the 8th power. Questions on that? All right, number 18. What do you do with that? Yep, a 1/2 power is a square root, right? So it's the square root of 64. And then distribute that 1/2 to your x to the -8th as well. So that's going to be x to the -4th. Okay. And now simplify from there. Square root of 64 is 8. What's x to the -4th? What do you have to do with that? Yeah, move it down. So we're going to go over x to the +4th because that gets rid of our negative, right? And we want no negative exponents. So move it down, x to the +4th, and that will be your simplest answer. Yeah.
Did you multiply the 1/2 of 64?
I didn't multiply it. I took it to that power, right? 64 to the 1/2 power is the same as saying the square root of 64.
Okay, and then you take 8.
That becomes 8. Yep. And then x to the -4th has to go on the bottom to become a +4th. Okay. 19, I would distribute the 24 to both of these things. And you can plug that into your calculator, right? -2/3 times 24. Or you can just do the mental math. That's fine too. So you would have on top, -2/3 of 24 is going to be a -16. Plug it into your calculator if you don't feel like doing that mental math. And then 3/4 times 24 is going to be 24 times 3 divided by 4. So that's going to be y to the 18th power. What do you have to do with that? You got to move the 16 down. So on bottom, you would have x to the 16th and y to the 18th. What's on top? A 1. If you get rid of all your exponents, there's just a 1 there. Okay. Yeah, Noah. Where'd 18 go? Oh, there we go. If it was, yeah, like these ones don't ever end up as plus or minus because they're never an equation. But yes, if it's x squared equals 64 and we had to figure out, then you would. But whenever there's a variable with that number portion, it won't ever be written as an equation. Yeah. Okay, number 20. Let's distribute again. -15 times both of these. So that's going to be x to the, now again, you may plug into your calculator 3/5 times a -15 and you will get what? -9. Same thing here, -1/3 times -15. You're just multiplying your exponents and you get y to the +5th power then. And then because you have that negative exponent, you just need to move it. So y to the 5th will stay in the numerator, but x to the 9th is going to move down. So that would be your answer. Okay. All right, 21. 81 to the -3/4 power. What's the first thing you would do? The whole thing. -3/4 is your number, right? So that negative is going to move us so that it's 1 over 81 to the +3/4 is what I would do first. And then 81 to the 3/4 power, you're going to think of that as 81, 4th rooting that, and then that whole thing we're going to cube, right? That's essentially the same thing. And honestly, at that point, check it in your calculator, right? You have a calculator that's going to show you that.
So if you were to do that with -3 instead, so you'd like to find -3 would be wrong, if you didn't put over 1.
What do you mean with a -3
Like,
instead?
If you put it over 1,
It would be wrong.
Okay.
Yeah, because the negative moves it to a denominator,
is
right?
that you only would do that if it was negative, like if it showed.
The negative is the only thing that moves it to the bottom, yeah, or from the bottom to the top. Yeah, negative, to get rid of a negative, it has to go from a numerator to a denominator or a denominator to a numerator.
But if it hadn't been negative in the problem, let's just say it was 3.
If- If it was just 81 to the 3/4 power, your answer will be whatever this comes out to. Yeah, yeah. Okay, so this is a 4th root of 81. Do you remember how to do a 4th root? Math on your calculator? You need to put in a 4 first, right? So you'll go 4 math, is it 5? Yeah, 4 math 5 will get you the 4th root. And then you can take that number and cube it. So 81 to the 3/4 power comes out to 3 cubed, which is 27. So this is 1 over 27. Okay. All right, number 22. This one, again, distribute. There's a whole lot of distributing with all of these guys. Okay, so 2 to the 4th power is 16. And then it's going to be x to the 20th, y to the 12th, and then z to the 0 times 4 is still z to the 0. What is z to the 0 power? Do you have a question? You add exponents if it's like 2x squared times x to the 4th, right? If there's another base to it, then we would add these. But when it's a power to a power, you multiply them. Yeah, maybe go back to those first 6-1 notes. Remember we did the 7 properties, 7 or 6? 7. Go back and look at those properties again. Just give yourself a little refresher in your 6-1 notes. That should be helpful. Okay, so z to the 0 to the 4 is z to the 0, which is 1. So don't write anything down. Don't write z to the 0 power. That's not simplest form, okay? So it would just look like this. Okay, number 23. So we're going to simplify here. What do you do with this? You have to subtract when you're dividing, right? So it's -3 minus 2 is x to the -5th power. Okay, 6 over 9 we can reduce. So divide both those by 3, we get 2 over 3. And then this one, again, subtract. 4 minus a -2 is actually 4 plus 2, so that's y to the +6th. So we're just going to move that x down. So it'll be 2y to the 6th and 3x to the 5th in the denominator. Okay. All right, keep moving here. 24, rewrite that in radical form. What's that going to look like? What root are you taking? A cube root, right? Your root is on bottoms, your index. So cube root, and then square that, or you can write it like this. Okay, either one of those is fine. You don't need to write both. Pick which one you like better. So how would you write this in exponential form? A to what power? The 3/5 power. Yeah. Okay. 26. What do you have to do first to solve for x? Got to add the 5. You have to isolate, okay? So get the radical by itself, +5 + 5. So the square root of 6x + 1 equals 5. Then what? Square it. Square both sides. So we get 6x + 1 equals 25. And now we're going to solve. Take away 1. Divide by 6. So x is 4. Okay. 27, what do you have to do with that? So we have isolated. What do you do, Jada? Yes, with both sides. Take both sides to the 2/3 power. Okay, so that gets rid of our exponent over here. So we just have 7x minus 3. What's 8 to the 2/3 power? You can plug that into your calculator. What do you get? The cube root of 8, which is 2. 2 squared is 4. And then from there, solve it. So 8 to the 2/3 power. I mean, you can plug it into your calculator. 8 caret, the little arrow thing, 2 divided by 3 will tell you 4. But it's also the cube root of 8, and then square that. The cube root of 8 is 2. 2 squared is 4. Okay. So 7x equals 7, divide by 7, so x is 1. Okay. Home stretch. Would you rather just finish this worksheet for your homework than do the book work for the homework?
Yes.
Okay, I'll change that. Yeah. 23. Okay. Here we go. 28. So you have the cube root of 8x to the 6th, y to the 10th. You're going to break that down, right? 8 is a perfect cube. What is the cube root of 8? 2. Okay. X to the 6th is a perfect cube. If you want, here, I don't want to confuse you. Here's how I did this in class, right? Perfect cubes, non-perfect cubes. So 8 is a perfect cube. X to the 6th is a perfect cube. Y to what power goes here? The 9th, right. Which means you have y to the 1st under your cube. So this is going to be 2x squared. Remember, you just divide these numbers. And then y to the 3rd. And then you take the cube root of y. Okay. Okay. I'm going to jump around a little just to make sure we get to all the different things here. And since we just did one like 28, I'm going to let you save 29 for your homework. Let's do 31. Sorry for the times. It should have just been a little dot, but it changed my formatting. So the first thing you're going to do here is you're going to multiply. 5 times 20 is 100. X to the what power? 3rd. Now is where you add them, right? X to the 1st times x squared is x to the 3rd. And then y to the 6th. Okay. Now you can break it into what's a perfect square and what's not a perfect square. What's a perfect square from 100? 100, right? You do the whole thing. How many x's? X to the 2nd power, which means there's going to be 1x left over here. And how many of your y's? All of them. Y to the 6th. Okay. So this is 10x y to the 3rd. And then you've got the square root of x. Okay. Okay, 34. Actually, 35. When you have this set up, how do you rationalize that? 5 plus the square root of 3, right? 5 plus the square root of 3. So what you're going to do on the bottom, remember the shortcut? What was the shortcut with this? Do you add or subtract? What? You could FOIL. You could FOIL everything. But you subtract if you're going to do the shortcut. A squared minus b squared. Okay, here's what we're going to say. If you want to finish this worksheet and turn it in for your homework, go for it. If you already did review B and you don't really feel like finishing this because you feel like you're good, then turn in review B. But don't do bookwork and worksheet. Pick one or the other to turn in and call it good. Okay, I will give you credit for either one. I want you to practice the problems.